In this lesson, we're going to talk about implementing a RAID array. Now, RAID stands for Redundant Array of Independent Disks. A long time ago, it used to stand for Redundant Array of Inexpensive Disks. It doesn't stand for that anymore. You'll hear people argue many times. What does RAID stand for? It's independent, inexpensive, independent, inexpensive. It stands for independent disks now. Now, in order to understand how a RAID array works, you need to understand 4 critical RAID concepts. Let's start with striping. When we implement striping in a RAID array, what we do is take data that's being written to the hard disk drive and split it in two such that it's written to 2 different hard drives at the same time. We could set up a RAID array that contains 2 hard disk drives, and we can stripe data across them. Let's say we have a chunk of data right here that's coming down from the operating system, and it needs to be written to disk. If we implement striping, we actually split that data up into chunks, and we write some of that data onto this hard drive, and we write the other part of that data over onto this hard drive. The key factor here is that we take the same chunk of data and we split it up so that it's written to 2 different hard drives at the same time. Over here, then you have this piece of the data and this piece of the data. On this hard drive, you have this piece of the data and this piece of the data saved. The key benefit to striping is speed. It all goes back to the old axiom that says many hands make light work. If you have to dig a hole and you're digging it by yourself, it takes a long time. If you have 2 people digging the same hole, it takes half the time, unless you talk a lot or something, right? Well, the same principle holds true when writing data to the hard drive. If we can have 2 heads on 2 different hard drives writing the data split in half, then we can write data theoretically 2 times as fast. In actuality, it's not quite 2 times as fast, but it's pretty close. It can dramatically increase the speed of your disk I/O operations. Same with reading data. Instead of having to read all that data off of 1 hard disk drive, we can read off of 2 hard disk drives at the same time, put the chunks back together to create the information. Striping is really good in a RAID array, but there's a problem with it. Can you see what it is? If you look over here, notice that we have some of the file on 1 hard drive and some of the file on a different hard disk drive. This can be problematic. What would happen over here if, say, this hard drive were to fail in this array? Well, we just lost half of every piece of data that's written to it. In this case, the data becomes corrupt. That's a problem. In fact, using striping alone in a RAID array does not increase fault tolerance on your system. In fact, it decreases fault tolerance on the system. And that's because you have multiple points of failure. If you lose 1 hard disk drive, all of your data is corrupt. That's a bad thing. Therefore, RAID includes a couple of other concepts to help protect the data, not just to speed it up, which striping does, but to actually make data redundant. The first of these is mirroring. Mirroring, you set up a 2-drive mirrored array, it will look a lot like the striped array that we saw up above. You have 2 hard disk drives, and they're connected together in an array. And that brings up an important point. Even though we have 2 hard disk drives in a striped array or 2 hard disk drives in a mirrored array, your operating system will actually see these 2 drives as one logical hard disk drive. It does not differentiate between the 2. It just sees it as one hard disk drive. For example, if we were setting up a hardware RAID array, these 2 disks together might be C:\/ on a Windows Server system. The operating system just sees it as one single hard disk drive, even though it's composed of 2 different hard disk drives. At any rate, back to mirroring. When we set up a mirrored array, if we have a piece of information that needs to be written to the hard disk drive, instead of splitting it up between the disks, with mirroring, we take this one piece of information here and we write a duplicate copy on both hard disk drives at the same time. It's not split up as with striping. It's a full copy written to both hard disk drives at the same time. Now, doing this does not increase the speed of the system at all like striping does, but what it does do is increase redundancy. If something bad were to happen to this hard disk drive and it were to go down, we're still okay because an exact copy of this data is written to this hard drive as well. In fact, most RAID systems can be configured such that if one drive in a mirrored array goes down, the other drive automatically takes over for it, and you don't lose any data. Nor does the system go down because users can still use this second hard disk drive. If they were working on a file and they were saving and opening and doing all kinds of things, and this drive were to go down, they will not notice any difference. They'll keep doing what they were doing, and it will keep being saved over here on this hard disk drive. Now, mirroring is good, but there is still a single point of failure. When we set up mirroring, we use one RAID controller to control the mirrored drive array. This one RAID controller represents a single point of failure. If something were to happen to the RAID controller itself, then we still lose all of our data, right? Say this RAID controller had an imperfection, or there was a problem during manufacturing, or it got shocked by ESD, or something happened to it to cause it to fail. Well, we lost all of our data still. Even though it was mirrored, both hard drives are no longer operable. That's a bad thing. In order to get around this, we can implement duplexing. Duplexing looks a lot like mirroring. We still have our two hard disk drives, but instead of connecting them to a single controller, what we do is connect one hard drive in the mirrored array to one RAID controller, and we connect the other hard disk drive in the mirrored array to a different RAID controller. Then when data needs to be written, it is written to both disks at the same time, just like with mirroring, but it goes through two different RAID controller boards. The advantage to this is if this board were to go bad for some reason, our disk I/O operations will continue. Users won't notice any difference because this RAID controller will take over and continue servicing requests using this hard disk drive until you have a chance to replace this part over here. There's one more RAID concept that you need to understand before we move on, and that is the concept of parity. Now, mirroring and duplexing works very, very nicely, but we don't get the speed advantage introduced by striping. Well, what if we want to use striping and we want to have some degree of redundancy or fault tolerance? Well, we can do that with parity. When we set up parity, what we do is we set up our striped array, and this one we're going to use two disks, and these disks use striping. But we add a third drive to the array. Depending on the RAID level, this could either be the entire disk or we might use just parts of the three disks. In this example, let's say we set up a striped array between these two disks right here, and then we add a third disk to the array that contains parity information. This parity information can be used to reconstruct data if something bad happens to one of the disks in the striped array. By doing this, we have created essentially a striped array that has some redundancy to it. In other words, if this disk were to go down, we can reconstruct the missing data from the parity information over here. Before we talk about RAID levels, which describe these different implementations, we need to talk about how we implement RAID itself. There's actually two different ways you can do it. Most of the time when you're implementing RAID, what you're going to do is actually purchase a RAID controller card and install it in your system. Many servers come with the RAID controller built into the system, and you don't actually have to install a card. Others, you will have to go out and purchase a card and install it. However, that's not the only way to do it. You could also implement RAID using software. Most network operating systems support software RAID. In other words, instead of using a hardware card to manage the RAID array, we use the CPU in the operating system to create the RAID array. Software RAID works very well. It's really easy to implement. It's a lot less expensive because you don't have to go out and purchase any RAID cards. However, it is slightly slower than using hardware RAID. With hardware RAID, we have a chip on the RAID card that is dedicated to doing nothing other than managing that RAID array. If we implement software RAID, then we have to use part of our CPU time to perform RAID operations instead of using the chip on the RAID card. Either way works. Given a choice, I would always go with hardware RAID over software RAID. Now, with that in mind, we need to talk about RAID levels. Let's start with RAID 0. RAID 0 is just simple, plain old striping. We talked about striping before, and we used this diagram. Well, RAID 0 is just that. It's striping data between two hard disk drives. As such, RAID 0 can dramatically increase the performance of I/O operations on your storage subsystem. It increases speed, but we talked about the disadvantages of striping. What were they? No redundancy, right? While RAID 0 can dramatically increase your throughput to and from the hard disk drive, it does not provide any redundancy. If this drive over here were to die, you've lost all the data on your system because your files are split between the two hard disks. We also have a RAID level called RAID 1. Before we go any farther, we do need to point out that many times folks who are new to RAID assume that the lower the number, the worse or less desirable the RAID level is, and the higher the number, the better the RAID level is, and that is not necessarily true. All this does is specify a certain way of configuring a RAID array. Depending on what you're trying to do, it might work great, it might not. So don't be confused. Don't assume that, say, a RAID 5 is better than a RAID 3, which is better than a RAID 1, which is better than a RAID 0. That's not the case. All it does is describe a certain way of implementing the hard drives in the array. If we're dealing with RAID 1, we're doing simple mirroring. As we talked about before, if you set up mirroring, you have two hard disk drives controlled by a single RAID controller. Whenever a write operation happens, the data is written to both hard drives in exact duplicate. If one drive were to die, the other drive can immediately take over and continue servicing clients, provides redundancy, fault tolerance, does not increase the speed of the system. In addition to RAID 0 and 1, we can have RAID 5 arrays. We may have an array that looks like this. If you're going to set up a RAID 5 array, you have to have a minimum of 3 disks. You can have more in the array if you want to, but you do have to have a minimum of 3 disks. What we do is we stripe across all 3 of the disks, which does dramatically increase performance, but we reserve one portion of each disk for parity information. RAID 5 works really well. However, it does have some weaknesses. One of the weaknesses with RAID 5 is that if you do have a failure, if one of the disks goes down, we do have parity information that can keep the array running, but performance is really lousy. If a disk fails, yes, we can still access our files, we can still open, save, do whatever it is we need to do, but the performance is really, really bad. There are many other RAID levels other than those we talked about here. These are the ones you have to know. It's quite interesting. If you want to go out on the internet and search for RAID, you can find many different web pages that will describe the various RAID levels. There's RAID 2 and RAID 6 and RAID 7 and so on, and you can see how these different configurations work.